Today I have with me Siddharth Garg, who's a professor at New York University. Straight off the bat, we can say that India is way behind US and China as far as AI research is concerned. They've been growing, but already that growth is flattening, right, which is very concerning.
You will not realize how much people are suddenly going back to the questions that you were asking in your research and saying, oh, can we use evolutionary computing for analog circuit design? Your paper and thesis and so on is going to inspire a lot of stuff going in the future.
So are we seeing a feedback loop here in the future where AI is making more powerful chips is making more powerful AI, and as some people say, this will create superhuman AI which will dominate humans.
There are clear potential harms that we have to protect against. So I tend to think of things empirically, quantifiably. What can I quantify as a harm right now, and what can I do about it? Right.
Quote unquote nuclear power is owned by private players,
Look, I mean, at the end of the day, if I'm building my application on top of, let's say, ChatGPT as an example, then much of the money is flowing outside India.
and the Chinese have shown that you can keep going up the ladder, creating new metrics as you do well.
So talent pool exists, know-how exists. I think we should encourage a proliferation of startups in the design space, in the silicon design space. Right?
What did you do to become popular science brilliant 10? Hello, everyone. Welcome to our show, Unboxing Intelligence. Today, I have with me Siddharth Garg, who's a professor at New York University. He is one of the few people who work at the intersection of artificial intelligence and chip design. He has won many awards. He has won an award for his PhD thesis, and it was around the same time when I didn't complete my PhD thesis and ran away from it. And he's also featured as Popular Science Brilliant 10, and most recently, he and his colleagues have designed a chip completely using AI. A piece of trivia is that Siddharth and I went to the same high school, and we were on the same bus for many, many years, and no prizes for guessing who was the smart one among both of us, right? So, with that, Siddharth, welcome to the show. Thanks for being here. And maybe I'll quickly ask you, what did you do to become Popular Science Brilliant 10?
A lot of marketing, but but technically speaking, I no, I had spent a fair amount of time at that stage in my career looking at supply chain issues for microelectronics. So at the time, and even now, in fact, those issues have exacerbated. Um, there's been, obviously, due to geopolitical reasons, a fairly stark realization that semiconductor manufacturing is not available in countries like the US and their allies, and potentially non-allied countries have a lion's share of semiconductor manufacturing resources and capabilities. And even if they exist in potentially allied countries right now, that might not continue to be the case in the future. So there was a very big interest at the time and now in shoring up semiconductor manufacturing at inside the United States, in other countries in Europe, and so on. Either that, or then using technological means to ensure that you can continue to fabricate semiconductors at untrusted foundries, but still provide security. And so, a lot of the work we had done at the time was seeking technological answers to this puzzle, basically.
Great, great. That's hard to copy. So I'm not going to feature in Brilliant 10 for sure. So that's going to the first segment of the show, right? Which is AI for chip design, right? And you and your colleagues designed this chip using AI.
Yeah.
So please tell us, what does this mean? What does this chip do? What did AI do in designing it? And where is it? Is it out of the fab now? Tested? It's fascinating. So just want to learn more about this.
Well, thank you, Varun. So when we started doing this research, and I'll credit some people shortly. But when we started doing this research, there was already on the horizon the idea that AI, and especially generative AI, large language models like ChatGPT, can help you write code. And so there were, essentially not commercial at the time, but certainly At the time, there were people who were experimenting with tools like Copilot, right? At the time, it was called Codex, I believe. And we were finding that for software, for C, C++, Codex would actually give us reasonable responses. And for an audience member who has not seen this, imagine, for instance, that you had to write code to sort a list of numbers. Now you could just say, please give me code to sort a list of numbers, and what will come
Yeah.
out would be several lines of code that could do that. Hardware is a little different. Actually, most people maybe don't realize that hardware is also designed um, in a programming language. So it's a different programming language. It's called. There are many. A very common one is Verilog, and but Verilog is much more complex than standard software. It's it's inherently parallel. It's very very kind of minute and fine grained and very difficult to learn relative to C and C++, for example. And so we were quite interested, intrigued about whether the same models could be used to write Verilog code. And so, as a first kind of illustration, a postdoc who was at NYU, Hammond Pierce, who's now a professor in Australia, sat down with ChatGPT, and his intent was to say, I'm not going to write a single line of Verilog code, right? I'm going to converse with ChatGPT entirely in English. I'm an expert. So when ChatGPT goes wrong, I will, instruct ChatGPT, hey, you made a mistake over there,
Yeah.
but I'm not going to write a single line of Verilog. And so this resulted in a kind of week-long effort where over that week, he was able to get ChatGPT to produce Verilog code that implemented a processor, a simple processor, but a processor nonetheless, that is fully capable because it hasn't, not to get too technical, but a fully capable but small processor.
It would have a clock. It would have code, memory. Yeah.
Exactly. And it had an instruction set that it had come up with, of course, with guidance that was what's called Turing complete. In other words, those set of instructions could execute any program in the world. And this was actually, let me step back one more second. Like, this was actually sparked by a competition that a company called eFabless had announced. Now, eFabless is a company that has come up in response to the global supply chain crisis that I had mentioned. So suddenly now there is this flowering of companies that provide very easy silicon design services. And so they had a competition, they announced a competition saying, we'll give you a very moderately sized little like piece of silicon, and you have to show us how AI can help in the design of chips, right? And so the entire project started in response to that, call. We were already thinking about AI for chip design anyway, but this seemed like the right moment to put it all together. And so what ended up happening was we sent this chip to the eFabless competition. We won that competition. eFabless has returned the manufactured silicon to us. It's been tested. Much of it, I think we got like 10 chips back or something. Most of them are actually sitting with Hammond in Australia. But they work. They can do simple things like turning on a light, and they can do more complex things if you want them to. Um, for us it was, I think, it's almost, it's an anecdotal story, right? Because it's the effort of one person or a few people, and it's not reproducible because it depends on your human insight and human, it's still reliant on human knowledge. But that was basically the proof of concept that I and I would say this, hopefully, because somebody from one of the big one of the big chip design companies said this in the conference that I was at, that using using ChatGPT and generative AI for chip design was not on their radar until we did this work. And so oftentimes I think of research not as necessarily potentially even advancing the state of the art in terms of see a new method, but basically introducing new ideas to communities, right? And it's that spark that communities need. In fact, many of the big chip design companies have taken this research a lot further than we did, right? But I do think that there was a little spark that I think, credit to all of the entire team, of course, that has catalyzed research in this area over the last year.
Very cool. And so that will it be correct to say this was the first chip designed using AI?
Yes, I think that's an accurate statement. In fact, as best as I know, there were some other entrants to that competition, but those did not use AI fully, right? And so the way that we had formulated this was, yeah, as I said before, that you're not allowed to write a single line of Verilog code by hand, right? So the design itself is coming entirely from ChatGPT, right? Despite the fact that it's quite heavily, prompted to like, hey, that little thing, maybe it should be, please think about that line of code that you wrote. It's almost like a first year undergraduate student, sitting and learning Verilog, and you're sitting with them. I'm like, I'm not going to write for you, okay, but I can help you. Yeah,
Wow, that's very cool. Congratulations.
thank you.
So, one question here, in a past life, I did some circuit design using genetic algorithms and genetic programming. We had met when I was doing that. And one feature when you would use genetic programming or genetic algorithms was that the circuits which came out were very funky, right?
Yeah.
So it was very different from how humans would have thought about designing a functionality. Did here was there anything which was funky or surprising, or it was the same boring way we do it?
Um, Well, let me say two things. Firstly, I will say that Varun, genuinely, your research is suddenly and should be suddenly very hot again. You will not realize how much people are suddenly going back to the questions that you were asking in your research, and saying, "Oh, can we use evolutionary computing for analog circuit design?" Yeah, again, and I think this time there might be different outcomes, and we can, if you're interested, we can speak why, right? Because the circuits were funky and hard to interpret, but still highly performant, if I remember. So I mean, sometimes you see these like cycles of research. So you should, yeah. So that's very cool stuff. No, because the interesting thing about machine learning, as opposed to, let's say, evolutionary algorithms, um, is that they are, in fact, machine learning models are incentivized to follow their training data. And where's the training data coming from? It's coming from humans. So indeed, right, like this is almost the opposite, right? Sometimes we struggle to get ML models to give creative solutions. So if you really think about this like span of creativity, right, evolutionary computing is on the extreme other end of creativity, right? And ML models are on the other end, extreme other end. And I do think that in the future, and this is why I think your work is going to inspire a lot of work, and I genuinely mean it. Your paper and thesis and so on is going to inspire a lot of stuff going in the future. Is that people aren't seeing this, but you cannot stay at the kind of like quote unquote boring staging, right? Because what we can do with AI even now is cut drudge work, right? We haven't done something where a chip designer wakes up and says, "Oh my god, that's a really cool design." What we've done is, "Oh my god, that would have taken a week. Now, okay, fine, we can do it in a day," right?
Sure. So the creativity is still limited, as you're saying.
To get to like the real power of evolutionary computing, I suspect that intelligently used, and I will say sparingly, right? You don't want to. It will take too long, I would imagine, to and I think this is, if you start from scratch, right? um, you end up with these funky designs because they look nothing like a human has produced, and they're also overly redundant because there's like lines of code that have been shipped in because that was right. Like you know this better than me. I think there's a massive use case of evolutionary computing by starting with a population of designs that have come from a model, ChatGPT, right, and then thinking about evolution on top of that. And when you kind of seed with a population that's relatively fit to begin with, right? And again, yeah, I'm not a eugenicist. I'm just saying these terms, technically speak, like from a purely technical standpoint. But you start with a population that is relatively fit to begin with, and start kind of doing, pairing and so on. You may get interpretable designs that will cause a designer to say, "Oh, that's cool."
Right. No, no, and it's interesting you say that because at that time when I was more active, there were approaches which was trying to do that, where they were giving some building blocks to evolutionary algorithms and then saying that can you combine these building blocks in interesting ways so that you are at a higher level of abstraction and don't get lost in having something totally funky.
Yeah, no, no, very good point. Very good point. Absolutely.
So this takes me to my next question, right? And I was earlier speaking to Anant Agarwal, and we
Hmm.
were discussing this thing, right? And because you mentioned analog, I thought I'll ask
Hmm.
you. So, analog was always tough to do. And then digital came in, which kind of put a layer of abstraction over analog. And that made, you know, doing digital much, much easier, right, than it was to do analog ever. And now I think we're going to see another revolution where it will become even easier because you have now the power of AI on top of it,
Yeah,
right? So does this mean that analog's going to be more dead than before, or you see that there's going to be a new opportunity uh,
yeah,
with analog,
I,
right? Of course, analog is necessary because world is
yes,
analog, so we need those
yes,
interfaces.
right,
But in many things which was analog was used before is replaced by digital. Will it speed it up,
yeah.
or how do you see it?
No, that's an incredibly interesting question, right? So let's leave out the interfaces because obviously, I think you and I will agree that interfaces have to be analog. In wireless chips, the analog interface is probably most of the power consumption, right? Your low noise amplifier and ADC and everything. Let's talk about compute. I think there's a lot of really interesting work being done right now in accelerating machine learning itself using analog compute. And in large part because machine learning is nothing but essentially multiplications of numbers and additions of numbers. And we kind of know how to do that in analog, right? You add two numbers, you basically take two wires and have their currents add up in some right. The challenge with that is scale. And so, one of the big challenges there is if you have and there's a DARPA program seeking to address this challenge. And DARPA, usually tries to pose extremely difficult bars, right? So they say, well, can you implement, let's say, 100 million parameter machine learning model entirely in analog, right? And
Hmm.
it's an interesting question. I think
Yeah.
the key question is, and they say the answer is no. The question is, well, can you do it without ever having to digitize? And the reason you have to digitize is that if you need to store something, um, then it needs to be in digital format. We haven't come up with good solutions for analog memories. And unfortunately, at that kind of scale, 100 million parameters, at some point or the other, you may need to digitize and store some intermediate results so you can do the next round of computation. And so if you're prohibited from digitizing, and that DARPA program kind of thinks of digitization as a cheat, right? Because you're actually then leveraging digital. But pure analog, pure end to end, I think is going to be a challenge, right? But I think there are lots of really important machine learning models that are very small. All of us have. Many of us have these like your phone, my phone, right? I say hello Siri, and it wakes up, right? Um, and that chip that's basically waking up your phone when you say hello Siri is the one part of your design that can never go to sleep, right? Because it always has
Oh,
to be on the
yeah.
lookout for, right? So it's called a keyword matcher. That little thing is only ever looking for one word, hello Siri, or whatever you call your chat assistant, right?
Yeah.
Um, and so those chips are small because they are solving machine learning tasks, but they're doing that, in a very, very constrained way, and they need to be low power because they're always running, right? So I can certainly think of an analog chip that does that, and I think that that analog chip might even be like an order of magnitude, like maybe like order of magnitude might be like, let's say, double, two times as power efficient in analog as it would be in digital, right?
So if we can do it, it will be very, very useful, is what you're saying, right? If you're able to do it analog, it will be power efficient, probably even speed efficient, and many of those other things.
100%, right? So in niche use cases, right? But unless we solve the reliable analog memory storage kind of problem, I think it's still going to be difficult for full blown analog computing.
It got me wondering, right, that uh, and I'm not a neuroscience expert, but is the brain analog or digital? And I think the human brain is mostly analog, right? But if, as far as I know, just to add, as far as I know, memory is still not properly understood among neuroscientists as to how humans store memory, where is it stored, and so on. So there's some evidence, but as far as I have read, they've cut different parts of the brain, and still memory comes from somewhere, which they anticipated it would not.
It's a fascinating point, right? I hadn't made that connection. You're right. It must be the case that brains implement memory, and it must be the case that you know that comes from somewhere. But yeah, look, I mean, maybe it requires us to like reimagine what it means to remember things, right? Because we have like these short-term memories, which are very different from long-term memory. We have things like deja vu, like we have all these, but it may require that reimagination of what memory means. So it's a good point. Yeah.
So that I was asking that, we saw it from the analog lens. But other than that, what do you see as both opportunities for entrepreneurs when we look at AI and CAD design, etc.? What are the hard problems? What are quick opportunities? Have you seen interesting startups come up around you in the Silicon Valley? Love to hear some examples and some thoughts.
Yeah, so I would say let's keep this aside, right? Which is that there's obviously, as you might know, probably hundreds of startups in that order doing acceleration of analog. So let's, there's certainly massive opportunity there, million ways to do the same thing, and what is going to bubble up to the top, right? As we'll see that in the next year, 2 years, 3 years. I think the AI for chip design is ripe for disruption, right? So we have had in the past three big companies, Synopsys, Cadence, and now Siemens, that provide that provide software that make it easier for you to design a chip, right? And to keep it a little bit at a slightly lower technical level of abstraction, right? But chips are incredibly complex things, and no one can design a modern chip by hand. And so there are already like hundreds of algorithms that take a description of a chip all the way to something that can be sent to a fabrication facility. This area is ripe for disruption because I think for the first time, machine learning is poised to make substantial dents in both simplifying existing tasks. For example, there was not a lot of assistance in writing Verilog code, right? So these Verilog coding assistants that I was mentioning to you can significantly improve designer productivity, right? And in fact, if you look at silicon companies, they spend a lot of effort on test and verification. And why is that? Because you cannot recompile silicon, right? You send it out to the fab, you spend millions of dollars, right? So your chip has to be right, a million times more, right? But, you have to be a lot more confident about the fact that what you're sending out is bug free than you need to be with software because you can't patch it, right? You manufacture it and you're stuck with that piece of silicon. So there's a massive spend in test and verification. And preliminary reports from industry, many people I have spoken to are beginning to use GPT and other language models to assist, for example, in test and verification, and are seeing like large wins, let's say, in productivity there. And as one of the people I spoke put it, right, there's this fear of job loss, and they said no, right? If 10 engineers were needed to test and verify a chip in the past, and I only need one in the future, I'll also be able to produce 100 times more chips. So
Yeah.
overall, because of just the proliferation of silicon designs that will be possible, I think overall it's a net benefit for all of us. So test and verification, writing Verilog code, these processes were not automated really in any way, and relied entirely on designer intuition. So I think there's a massive opportunity there. And then once you have your Verilog code, then it goes through a 6-month process where you need to take that code and convert it into basically a blueprint that is sent to a chip fabrication facility, and that is also very painful, very laborious. You have to like do all types of magic to get your chip to meet power constraints and so on. And a
Right.
lot of that intuition that EDA engineers bring with them over years and years of experience can be coded in some sense in a machine learning model, right?
Hmm.
And even if they don't give you the final answer, they'll give you much better starting points than before,
Right.
right? So I also expect to see a large reduction in time to market from that initial Verilog to the blueprint that is sent to a foundry for fabrication. And the third thing I'll say is I think, what I call like superhuman outcomes. And why do I say that, right? So if you think about, AlphaGo. So Go, for the audience who might not be familiar, Go is a kind of game, two-player game like chess, much more complicated actually. And a few years back, Google's DeepMind agent was able to defeat the world's best player, right? That was considered unimaginable. But on top of that, it beat the world's best player using moves that every Go expert at the time was saying, I don't understand. Like, this looks like a not so great move. And only later, post facto, did people realize that there was actually a lot of like smarts in that move too. And so this is, I think, going back to this question of creativity, right? The act, removing drudge work is the icing on the cake, right? The cake itself is enabling an entirely new, maybe potentially introducing entirely new, uh, designs that we haven't seen before.
Sure, sure. Now that's a good segue to my next question, Siddharth. And this is partly philosophical, partly futuristic. But uh, what I'm hearing is that AI is designing chips now, right, and helping us make better and better chips. And you just said use the word superhuman, right? So probably AI will create superhuman chips, and chips are what is driving AI these days, right? So it's more and more compute, which is become the bread and butter or the oil for AI. So are we seeing a feedback loop here in the future where AI is making more powerful chips is making more powerful AI. And as some people say, this will create superhuman AI, which will dominate humans. So is this something?
So if I can, I'll break it down, right? So let's keep the kind of let's. There's two separate questions here about the flywheel effect of
Yeah,
better AI, better chips, better AI, and we saw that in the past with what is called Moore's law. And just again, for a non-technical audience, Moore's law basically said every 2 years, roughly 2 years, um, technology improvements will allow us to get you know much more capable chips, and that has happened, right? Indeed, those capable chips have helped exploit Moore's law, allowing us to design the next generation of more capable chips, right? So that flywheel effect we have seen in the past, and I do think that that flywheel effect is going to be at play here. I don't know how strong that feedback loop will be, but I do think that feedback loop will be set up and will allow for more innovation in this space, in the chip design space, quicker. And as you said, those faster chips will result in the maybe stronger AI. So let's keep that aside. I think I use the word superhuman, so I'm guilty of it, right? So now I can take it back. Yes. So there are these questions about AI becoming all powerful and things like this. And the one thing I know is I think we are all as humans not great at predicting technology past like a small 2 year window. So like your hypothetical flywheel may take effect in the couple years. So I'm more confident making a claim on that. I just don't think that if we look back, that any of us could have predicted what social media would mean for us today, or what well, let's say aircraft travel, or even laptops. Right? Remember a very famous person saying that who cares about a laptop, right? Um, so I think it would be a bit of hubris on our part, right, to make such a bold declaration. um, I think what we have to do is to be constantly on the lookout for any harms and dangers that AI poses in the now and in the 1 year, in the 2 year, in the 3 year time frame, and then kind of make that. Because look, I mean, if Skynet is going to be active, like I have no clue in 50 years what that's going to look like. So what can I do about that today, right? But what I can do is I can say, look, I mean, if you're using AI in medical decision making, or if you're using AI in giving people legal advice, right? What does that mean? And or if you're using AI in autonomous driving, right, with driverless cars, um, there are clear potential harms that we have to protect against. So I tend to think of things empirically, quantifiably. What can I quantify as a harm right now, and what can I do about it, right? And then this like 10 year, 20 year time frame. It's a fascinating question. It's a fascinating philosophical question, I think. I
right.
just don't know. So yeah.
Sure, sure, sure. Yeah. Okay. No, and I agree. I think it's much more important to deal with the issues which are here and now, right? And I know you have also done work around fairness and bias in AI, right? And looking at some of those issues. also in recruitment. And because we are touching here, maybe you can speak for a few minutes on what did you see when you, I think, correct me if I'm wrong, you're basically testing LLMs to see if LLMs are recommending candidates, how would they behave. So love to hear what did you find.
Yeah, and actually, let me preface that with something that I was meaning to mention, which is, look, I mean, as you know, AI and machine learning models today are still heavily reliant on massive training data sets and will pick up the biases inside the data set. Okay, so we last year did a study on this is a different topic, and I'll come back to the one you asked me about. We did a study on how many on the bug incidents, right? How buggy is AI generated code? Okay, and I was very interested in that problem, and we set up this kind of randomized control trial. And then we looked at the results and we came to the conclusion, AI's bug incidents, right? How frequently bugs appear in AI generated code is actually very closely matched with how frequently bugs appear in human generated code,
Oh, interesting.
right? And then, right, exactly, that was my first response. And we spent some time thinking about it. And it's like, yeah, I mean, you know, that your model is replicating, is emulating its training data. So in retrospect, why would I expect anything different, right? So I think the same lesson applies to CV evaluations, which is, you know, there's clear bias. We know that there's bias from many studies in the way that humans evaluate other people, and obviously evaluate CVs from CVs that they're getting in. And so we did a fairly comprehensive study and found, for instance, there do exist biases in automated CV evaluation models. For instance, on the basis of political affiliation, hobbies, uh, importantly for I think us going forward, you know, maternity leave status, right? If you've a lot of people, both men and women now, will take a year off or 2 years off from work because they have 4-year-old kids or 5-year-old kids, and they feel that that's a critical time in their child's. I know you have a young child, right? And you can see how formative. I met him briefly. How formative these years are, and you know, it's reasonable for parents to want to be with them, but the question is like, what impact does that have on your CV when you reapply for jobs? And we found that AI models do quite poorly and tend to say, or tend to be biased against people who have those gaps in their CVs. And I think, you know, these are all important questions for us to think of.
And
Is
as you think, that's a reflection of how it happens in the real world, right? Because
that's a
yeah.
reflection, you know, because your first response is, oh, like was she or he, like, does that imply that they'll do it again? Does that imply they're not sufficiently motivated about their jobs? Um, you know, and this is of course a normative question. I have a point of view on that, right? It implies that someone had different priorities for a couple of years, right? Why does that mean that they can't come back and become an equally excellent lawyer, right? But yeah,
No, that's very interesting. AI is just showing us a mirror, right,
it,
to
it,
our.
it is a great way of putting it. It's just a mirror. It's mirroring, you know, our own thought processes.
No, it's interesting, right? Because when a lot of people, again, in our work at Aspiring Minds, and we are doing assessments, right? And there's all this discussion about biases in assessments. And the interesting thing which I find there is that it's easy to measure when you have a quantitative process, the bias and so on, right? Whereas when humans do it, uh, the bias is still there. It's just that we are not detecting it. But I think what is AI doing is that because you are training it on that data, it is helping you quantify and see that bias actually also existed in the human process to begin with.
Absolutely, and go ahead. Yeah.
So that's good time to go to our second segment, which is now chips for AI, right? So we've discussed AI for chips, so we'll do the reverse. So just to start with, right, we see a world suddenly where in the last few years, GPUs have become very important for AI, right? And this was not so even probably 7 8 years back, right? So what really did happen to AI that compute, especially compute on GPUs, has become so important?
Yeah, so you know, one of the things that happened, I guess, is this transition from around 2012, right? So people had been doing neural networks before that, and you know, for the first time in 2012, around that time frame, um, it became fairly clear that neural networks were outperforming other solutions, support vector machines, for instance, and other solutions in that space. Um, but neural networks, in fact, we are seeing this with large language models, what they call quote unquote scaling laws. which is, larger models are better, right?
Yeah.
Simply put, there's a lot of like asterisks there, and like people will disagree. But for a non-technical audience, I think it's fair to say that the scale of the model is important, and larger models tend to perform better than smaller models. And so the size of machine learning models have like dramatically increased in the last few years, even certainly since 2012, right? To where we are now, where we're seeing trillion parameter models, or billion parameter models. But really, if you think about the computation, surprisingly, maybe not surprisingly, right, the computations happening inside a model are actually relatively simple. They're these computations that we call matrix multiplications. Essentially, as I said, multiplying and adding numbers. And there are lots and lots of numbers that need to be multiplied and added together, and those multiplications can all happen together at the same time in parallel. And of course, GPUs were first designed for different reasons, right? Because we needed to do faster image processing, video games, all of these things. But there too, there were similar computational patterns. And as a consequence, GPUs tend to have lots and lots of like little compute units that can do these multiplications and additions. And there's thousands of them on a GPU. So the reason that GPUs have gained so much prominence is, on the one hand, machine learning models need to do millions, billions, trillions of multiplications and additions, and many of those can be done in parallel. And on the other side, GPUs give you the capability of doing that, right? The parallelism that you get from GPUs. And again, for a lay audience, think about when you go and buy a processor in the market. And when you go and buy a processor in the market, like they will tell you, oh, it's a four-core Intel something something, right? Or four-core AMD. So four is this kind of, there are four processors inside your chip, right? And you can do four parallel lines of computations at the same time, right?
Right.
Eight lines, eight threads
Yeah.
of computation at the same time. GPUs do, thousands of threads of computation,
Interesting.
parallel computation.
Yeah, yeah, no, makes a lot of sense with that. So that do you think now availability of GPUs and compute has become a gating function to do high quality AI work, right? And who doesn't have access to GPUs is kind of screwed. Is that right?
Yeah, I think I think we talk a little bit about superhuman AI, right? But there's a like clear GPU hegemony of sorts that is
Yeah, yeah,
emerging, right? Because there's only one company. There's a second one, right? Without naming names, I think there's reason to look at the second one as well. And maybe I'll name names. I don't think
yeah.
it's
You can
like
name it.
Qualcomm and AMD, since it's not. Um, but yeah, I mean, look, let's start with academia, right? We are thirsting for GPU resources. We really are, and these are expensive. And I, I forget a professor at Berkeley. I forget whether it was Dawn Song. It wasn't. I forget her. I'm just blanking out the name as I usually do. Was making the case that even at Berkeley, right, well, very well funded university, that in her own research lab she only has, and again I don't remember the number offhand, but a minuscule number of GPUs. So what does that mean for the rest of us who do open science and open research
Yeah,
to even replicate results that are
right,
claimed by companies, right? So that's the one thing. The other thing is that if you're a startup provider, not provider, let's say a startup, right, or you're a smaller, oftentimes GPUs are on back order, right? And so what do you do? Like now, okay, I've just started my company, you know, great idea, a lot of investment, and GPUs are in back order. So then what am I going to do? Now you can go to a cloud service provider, but then they have a significant markup over owning and running your own data center. So these are all of these questions, I think, are intersected. The global supply chain for manufacturing, is again implicated, right? Because we need to be able to manufacture these at a faster pace, probably. But we also want to do this in a secure manner, perhaps onshore, right? So I think there's a lot of kind of currents, right, that are under the surface, really. But the top level answer is GPUs are blazingly fast because they do lots of parallel computations, right? And like many orders of magnitude more than what your CPU does.
So that, you painted a lot of issues, right? And with how compute and GPUs have become the gating function for good AI research and the challenges with it. And you mentioned the hegemony of, let's say, one or couple of companies on it. But what's the answer? I mean, how do you see that there could be a democratization in the future of it being more available, free, right? I mean, humanity has generally moved towards finding ways to democratize resources which create efficiency, right? And I mean, we have seen it in very violent ways happening earlier, right? And when land was the resource, which was the determiner, and so on.
And led to
Uh,
like years of colonialism, right?
Exactly, right.
Yes.
So, do you see? I mean, any if we go back to the past, if has certain such things happened in other domains, and then they've led to democratization. Like I can think of human genome. The being able to create the human genome and label it, and it was like very expensive, and now it's democratized. So, do you see any such? I mean, can you think of any such answers coming in the next few years or decades? And if you also know of efforts which are trying to do that.
Well, I mean, I will point to, and again, I'll paraphrase because I didn't read that conversation in much detail. But Sam Altman apparently at some point was referring to how GPU might be the new currency of the future. And I don't know if you saw that interview. It's
No, I
certainly
didn't.
food for thought, right? I wouldn't say like advocate for or against that. Because I too have not read the whole thing in detail. But there was some comment about how everybody in the future should maybe have access to a GPU, something like this, right?
Yeah,
And that becomes a currency. I do think that there's going to have to be some way for whether it's through academia industry collaboration, whether governments provide nationalized access to some sorts of like GPU resources. And I will say, like we keep saying GPU, and I'll kind of let's call them AI accelerators, right? Because I don't want to be biased in the favor of GPU specifically, as you mentioned, right? There's analog computing. There's so many startups that are trying to um, supplant GPUs as the platform of choice, right? So I certainly see democratization in the choices that people will have as to whether they want to use a GPU, whether they want to use a GPU from Qualcomm or from AMD or a specialized AI accelerator, right? Google has one called the TPU, right? So there could be other options too. So let's say AI accelerators broadly. I think there's certainly going to be a lot of competition in this space, and I think competition means innovation, and I think there will be many different solutions on the market. But regardless of that, um, let's just take this like everybody should have a GPU. I'll just make it up, right? Just for the purpose of
yep,
a debate,
argument.
okay?
Yep,
Yeah, for the purpose, everybody should have a GPU. There are 6 billion people. The way the technology moves will probably be obsolete in a year and a half. Let's just be optimistic. Let's be let's kind of push the boundaries and say that every year every human being will need a new GPU. Well, okay, sure, or new AI accelerator. Can we manufacture 6 billion pieces of silicon on a yearly basis? We don't have that capacity, right? So the bottlenecks may not just be innovation, right? The bottlenecks are um, what is the manufacturing capabilities that are available right now, and can they kind of keep pace with demand? And it appears to be the case that so far there have been these supply chain issues. I think, as you know, there are the geopolitical moves around embargoes, and that too, right? I mean, I'm not an economist, so I won't take a view on that, but I think we have to be mindful that there might be, for all embargoes may have net positive outcomes because it's going to
right.
force the embargoed
Yeah,
countries that have extremely strong technical resources of their own uh, to innovate in that space, right? So the third thing, though, at the end of the day, is that one GPU is not enough, right? Like one GPU per person,
exactly.
uh, right? And so that's where if you need 10,000 GPUs to train your model over a month or whatever, let's just make that number up two. Then it's not that I can train. Okay, so I have my one puny GPU. What am I going to do with it? Right? So I
Yep,
need to compete. I need to be able to, right? And so this maybe I close the loop by saying this leads us to this idea of foundation models, right? That people can download and then tailor and fine tune
yep,
for their own needs. And indeed, that can be done, right, to some
at a
extent
scale.
at a
Yep,
cheaper cost. But what does that mean, right? It means that I have no visibility into the training data for that foundation model that I have just downloaded, right? And oftentimes companies will say, you send us your data and we'll train, in the
Correct.
background, and we'll send you back the model. And then that, you know, that's deeply to me troublesome, because ultimately then we are reposing faith in a small number of companies that have released those models. And because these models are so complex and uninterpretable, to your point about uninterpretable analog circuits, I just don't know what types of behaviors are embedded, right? And I do not think we can assume that these companies will be good actors, right? I hope net they are positively inclined, right, to the good of humanity. But I'll give you a very simple example, right? This controversy around OpenAI having used Scarlett Johansson's voice, or at least tried to create a facsimile of it, without not
Litigation.
without her consent, with her clear negative consent, which is
Yep.
no, right? So so there's a little bit like of this what I would call like cowboyism, right? Like this, like, oh, nothing matters, nothing's gonna. And I think regulation may play a role, right? But the core question, let me just get back, sorry, to the core question. There is a smart kid, let's say in Trichy, India, right now. There probably is, right? There are smart kids everywhere. And it's a great new idea for a model that is not a transformer, which is what people use right now, right?
Yep.
How is that kid who has this fantastic idea going to prove that it can outperform ChatGPT, because they will never be able to get the data and the model, and data being another resource, right? That is
Yep.
being siloed and void. They will not have the data and or resources to train a model of that size, and they could train a smaller model, and people will say, sure, but I have no idea how it scales,
Right.
right?
Right.
So
Fair
if, say,
point.
and I'll conclude. Sorry, because this I'm passionate about, right? I think the Indian government or governments all over the world um, can play a huge role in incentivizing that 17-year-old kid, with this amazing new idea, or 20-year-old kid, or whatever. You should be able to somehow, maybe create a national data center of sorts, where there's, of course, competitive access to those resources, but that access is available to all who can convince, maybe a panel of
Yep.
experts that they have this cool new thing, and they have they need 10,000 GPUs. And perhaps, I don't know, like maybe that organization keeps a small percentage of, future patent profit. Well, however, you know better how it
Some
works, right?
some part of the
Like,
IP.
yeah, yeah. So, I mean, I have not seen that come up in any country, and it's very surprising to me that countries can, yeah, countries can make those investments, and they can open up access again to competitively, reviewed proposals as to what they're going to do with that resource. And so I would love to see that happen. I mean, whether.
No, no, absolutely. So that right, and I think that takes us to our next segment, which was around India, right? And in India, there's one initiative which is trying to create, digital public infrastructure around compute, buy compute in bulk, but also create standards to use distributed compute, uh, across multiple users and so on. And if I hear you right, you think that's the way to go, probably.
Yeah, yeah, I definitely think that's the way to go, because um, the alternative is a very small number of well capitalized companies, right? And
Right.
you know that, right? That there's a fair amount of concentration of investment in a few companies who have, to their credit, innovated and, kind of brought us to this point. Fair, in fairness. But if they, this feedback loop, right, where only they then can afford the GPU resources for the next round of training, is deeply disturbing. And I think might set up India to be like, what I would call like a form of digital colonialism, right? Where, look, I mean, at the end of the day, if I'm building my application on top of, let's say, ChatGPT as an example, then much of the money is flowing outside India
Yeah, yeah. Yeah.
from
So let
Indian
me ask you,
customers.
another related question, and again, a little futuristic, right? But
Yeah,
do you think like GPU and compute and efficient compute, ownership of that is almost like kind of will become something like ownership of nuclear power, right? And today, at least, nuclear power is owned by countries and there are international laws and there's diplomacy and a lot of tools which people have to manage it. But here, this quote unquote nuclear power is owned by private players, right? who are regulated in very different ways, but not really,
Yes.
yeah, not really in the way governments are regulated, right? So, do you see that possibility happening?
I think, look, I mean, you, I meant you. I know you didn't mean it that way, but like, of course, nuclear power and let's say GPU training power are two different sorts of extremely powerful. One is a weapon, the other perhaps is not. But like, one way or the other, the point is that there's this kind of dominant market position, right? I think there's need for more regulation. I don't think the government is going to. I don't think we'll be at the point where you nationalize these resources, right? Of course, nuclear power resources are nationalized. Um, but we saw with like in fairness with like space science that players were able to disrupt that a little bit as well. At any rate, I think this is going to continue to be in the private sphere, private ownership, but there's going to be, I hope, a few layers of regulation around
Mhm.
that. For example, like if you're claiming to release a foundation model, then you really do need to release, maybe not to the public, but perhaps a regulatory authority,
Yeah.
um, your data, right? Your data sources, your training processes, and so on. And then, get some sort of certification, which we do with food and drugs and all types of things, right? To say that, look, the government has certified this medication to have certain standards. So, that's I guess one route. But yeah, like I think, unfortunately, we are currently engaged in a war, let's say, quote unquote, not a weapons war, well, of course, but but there's like geopolitical war where we're going to create two camps, right, as an unfortunate consequence of policy from
Yeah.
both sides. And I think that like that, these two camps are equally capable of having, millions of GPUs, and I don't know what that means for the future of AI and computing, to have like this bifurcation of sorts. I certainly don't think from a academic research standpoint it's a good idea. We saw that in the Cold War, right, where Russian scientists were not allowed to, right? And from studying, you and I both, from like our grade 11 and 12, as we found out, right, most theorems, most results were known in Russia, or sometimes in the US, and then they would not even know that the other person has
Right.
published a
Right.
paper that does the same thing, right? I don't think that's good for science, to be honest, right? Geopolitics aside.
So no, interesting, Siddharth. And just to, because we are on the point of geopolitics, right? And one of the things which is happening in India right now is that there's this big semiconductor mission which is announced, and India is trying to put together a fab in India. And again, there are two counter views on this, right? So I'll lay out those counter views for you and love to have your input, So one of the views is that India should really do this. This is an important part of the value chain. We already have IP design companies in the country. We should be there at the other parts of the value chain. Because of geopolitics, we should be self-reliant and we should do this. The other part of the argument says that, look, this is very energy inefficient to do. India's resources will get eaten up. It doesn't create as many jobs per dollar spent. And even if we put a fab today, we will never be, others will move much faster than us, and we'll never be in the real race for it with the resources we can allocate to it. So, where do you stand on this debate? How should India be thinking about this?
Well, so let's look at a few analogies, right? So one, semiconductor fabrication is not a point solution. You can't set up a fab and then it does the same things for the next 10 years, right? There's the most advanced fabs continue to try and innovate and push the boundaries every year, every 2 years. And so to the extent that Moore's law is quote unquote coming to an end, there's a lot of other um, firstly, it's not entirely come to an end, and secondly, there's novel technologies and so on. So I would say, well, if you want to get into that game of being at the cutting edge, the investments are massive, as you pointed out, massive, right? Uh, that will take away from our other priorities, and the investments, as you said, may not even produce that many jobs, right? Um, and even actually, like countries that are better positioned have found it difficult to get, say, a company like TSMC to set up a shop in the United States that is truly at the bleeding edge. That even here it's been an issue, right? Manpower, all manners of reasons. And I think it would be a little, unless we plan to put in so many resources that you can fully exploit advanced fabricating, having an advanced fab in India, right? The flip side of that is that, in fact, I think there's value to have not an advanced fab, but perhaps a fabrication facility in a somewhat more mature technology, right? And the reason for that is those machines are cheaper, and I think because of the benefits of custom acceleration, right? Then you'll still find users of that mature technology because your design, fabricated there, even in a mature technology, would probably be more efficient than running the same code on a processor. So if you're a drone manufacturer, for example, you may still see benefits from being able to manufacture. This does a few things, right? The investments are lower, um, and it does provide our internal, say, defense, space missions, and so on, some degree of access to you know, to a trusted foundry. I believe one existed in Chandigarh, so I don't know, you know, where we are on that.
Sure. You're seeing the fab at in Chandigarh, right?
Yeah, I think there was one, so I don't
Yeah,
know.
I think there was one, but maybe
Yeah,
they never upgraded and they just
right. But I do think that countries are finding. Look, I mean, advanced, like the bleeding edge is totally different. Of course, my initial opinion is that's a bad idea, right? And I think maybe there's value to doing a study of, as you said, the job creation potential, strategic advantages, and all these things. I just don't see that happening. I haven't seen that happen in the US either. In part because the US already does have some has Intel as an advanced fab, but getting other players to come in has been challenging at that advanced node. But I do think, again, right, like 5 years back, the technology of 5 years back, right, is still in use. Not everybody wants to pay the cost of like getting a chip
exactly.
fabricated, right? And so there are many, many, many use cases of mature technologies, and I think this would be a place to start. Maybe build know-how, maybe build knowledge. You'll be a little bit behind, there's no question, but then maybe get ahead on the design side, right? And I think getting ahead on the design side, which we arguably might even be because most large companies have massive silicon design operations in India. So talent pool exists, know-how exists. I think we should encourage a proliferation of startups in the design space, in the silicon design space, right?
Yeah, and I think we have a good ecosystem there. So I think,
Massive, a
yeah,
very good ecosystem, great educational potential. So those pieces fit in place much more easily for me than the manufacturing side,
sure, sure.
right?
So for that, one more question in this leg, right? Again, thinking about India, and so if you again look at AI and India, and straight off the bat, we can say that India is way behind US and China as far as AI research is concerned, right? And interestingly, we were looking at some data recently, and we saw that papers in good conferences in India are small. They've been growing, but already that growth is flattening, right? Which is very very concerning, right?
Yes.
Uh, what do you see are possibilities for India to do? Is it specific areas of AI research they should focus on, uh, or how should they really, be in the game, if I may, right?
Yeah, yeah, no, that's a great question. So I think I will start by noting, and let me say that this is my anecdotal observation. This is not quantitative, right? This is my qualitative observation, which is I find that you'll agree, Varun, with me that there are, you know, brilliant minds at leading technological institutions in India, certainly well past my capabilities. Okay, very smart people, classmates of mine. Maybe I'm sure some of yours, and I've known those people for years and years, and they have incredible um, talent, right? As do the students who are going to the ISCs and the IITs to do MS and PhDs, right? So I think there are a couple of things, right? There's obviously in the AI space a question of resources. And so, in fact, we are seeing this even with China, where I feel like they have more researchers get more, compute resources than we do here in the US. And I think I would suspect it's lower, but that is just a gut feeling that it's even more difficult to get like 10A100s or high end resources to train your own model, right? Number one, that has to be addressed. um, and the second piece of it, which goes back to your question about why are there not more Indian publications at NeurIPS, to pick one example, I think what happens, and this is again my observation, is you move a lot of folks. Uh, now in fact there are internal chains where professors are graduating with PhDs from Indian institutions, joining ISC and IIT. is fantastic. And of course, several still coming back from the US. I think you get caught in this dichotomy of, look, I am in a place where technology can have massive value within India to solve India specific problems, right?
Right.
And if I were there, I too would look around and say, well, look, I mean, there are immediate needs of the Indian people for which there need to be indigenous solutions, let's say. And we see that with language models, right? There clearly is a need for indigenous solutions because which country in the world has like 24 official languages? I'm sorry if I got that wrong.
Yep.
24. Um, and probably 100 others, if not more, that are spoken all over the country, right? So that's an India specific problem. Um, but there are, I mean, I don't think, but we can't leave aside fundamental science, right? Like we can't leave aside that, look, I know these are problems, these are pressing, I can make an impact. Okay, so then you're like, well, if I can make an impact, I'm going to do it now. Innovation in fundamental sciences takes more time to show impact, right? But for us to be leaders, I think the one thing I would say is that, even grant agencies, maybe tenure. I know there's no official kind of like notion of tenure, which is what I'm not saying that's either good or bad. Um, but I think we should benchmark ourselves by cutting it right. Say there's all this great work that is happening to translate technologies to help uh, people in India that have different needs compared to in part because we're a developing country, in part because we are such a diverse country, all of these things. Um, but we do need to say, well, look at like what percentage of our just amazing brain pool in academia should be working on fundamental problems. And I think there's been a skew in that direction, right? And there are these Indian conferences for AI and wireless communications, and they all have good talks and speakers. But I think we need to say, well, look, I mean, there has to be some sort of benchmarking, as you have done, to say where are we on the global scale on fundamental research. Because if we get left behind there, we'll always end up being consumers of
Yep.
external technology, right? We saw that in the wireless space. There were valiant efforts to create to provide last mile or mobile telephony to rural India that just got supplanted by the fact that 2G, 3G, 4G, and 5G wireless has just become so cheap, right? So suddenly, what has happened, right? The people who did the fundamental research, generic research, were able to use scale, just for instance, right? Just economies of scale uh, to supplant indigenous research that was much more tailored, right? This is not an argument against that. I'm just pointing out
So we need to
that
do
you
both.
cannot, yeah, like you really have to create incentives, structures that incentivize both. And then maybe some people will choose to do one and another set will choose to do the other, but I don't see that other set happening right now. Like at the you've seen it already, right? We have fewer representative publications at top machine learning venues. And there is no doubt in my mind that if there were good incentives, that India would be um, publishing just in. I'll tell you my personal story just very very briefly. Right, I come and give talks at academic institutions about my research, and the ideas that we have, the conversations that I have with students and professors, are incredibly technically sophisticated. I would argue far more so sometimes, as a result of talks outside of at other institutions that are, quote unquote leaders. But then somehow that does not translate. Right. So
No, I think you're bang on, right? Like, and we have an example India with the economic reforms, right? Before 1990s, there was this Hindu rate of growth where again we are talented people, but somehow the belief was that India can't grow more than 3-4%, and we
yeah,
just aligned the incentives right, and the economy took off. And probably
yeah.
if there are the right kind of reforms in higher education and in science and technology, which is getting the right incentives, simplifying the rules, and so on and so forth, making the grant making efficient, we can see very similar results as we saw for the uh, economic growth.
And add that, like some of these mechanisms to incentivize basic research are very crude and sound awful. But China and Australia, I believe, have these rankings of conferences and this and that, and they call them A star and A and B
Yeah.
star and whatever, right? Okay, not a huge fan of like this sort of categorization, right? Because great work can be published anywhere, even on archive these days, by the way, right? Um, but maybe it is useful to like start that flywheel, right? Maybe it is useful as a way to. next
Good
5 years
strategy.
to have similar metrics. As much as I dislike, but we have to start somewhere. I think it's a crude metric, but it'll get the job done.
No,
You
and I
know,
think Siddharth, we again have this example of China, right? It first used these crude metrics to,
yes,
you know, get up the game, right? And now what I hear is that the latest in China is they say, oh, citations are useless, right? So this is no more the metric, right? We have already maxed this out. So what's next, right? So I think it's almost a ladder, right? That and Chinese have shown that you can keep going up the ladder, creating new metrics as you do well in the
no questions, right? Because right now, so I'll give you one trivial example, right? I don't know if they've done this, right? But top machine learning conferences are very selective, fine. But they're, in addition, there are layers within layers, right? So at NeurIPS and ICML, there's like a very small fraction of papers that get to talk about their research in this giant auditorium.
yeah,
It's called oral
yeah,
presentation, while most people would present posters, even despite having gone through a selective process, right? So I can totally see, and I don't know if China is doing it. I'm sure they're now incentivizing these oral presentations
yeah,
over like,
yeah.
let's say,
Sure they
poster
are.
presentations. Yeah, it can get more and more fine grained, right? And citations are not, a great metric at all. But there, somebody pointed this out, and it was kind of interesting, right? Which is, but they're correlated, right? And that correlation
Yeah,
could
yeah.
be very right. So that correlation could be very weak. But when you build a feedback, let's say when you build like feedback control systems, you don't need perfect correlation. You just need positive correlation, right? That there's a measurable right thing that is positively correlated with the quality of research domain, if not poorly correlated, but certainly positively.
Sure. Directionally, it should be going in the right direction.
Directionally, it should be in the right direction, right? I know we do these analyses right within India, but I don't know what happens past having seen that we do poorly on these metrics. What is the next step? So how am I going to target this metric, and certainly how am I going to target translation of technology to the Indian consumer? I think we do that, Indian market. I think we do that a lot better, right? uh, than we do the first. Yeah,
No, agreed. Agreed, Siddharth. So, Siddharth, we have, tried to cover a lot of ground today, tried to solve the world, chips, AI,
yeah.
and whatnot. Let me ask you now two more personal questions, right? One, let me ask you what keeps you excited these days, right? What is the kind of work you're doing? You told us about AI and chip design, but what are some of the areas you and your students are working on? What do you see? What makes your eyes glow? Right now. Yeah.
So I spoke a lot about my AI research, and indeed, like I would say, half, if not more, of my lab is kind of continuing along the ideas that I discussed. The other, I think, there's what keeps me excited. So there's this beautiful world of cryptography that I discovered in say 2016, 2015, 2016, and cryptography is incredibly difficult to pick up, right? Neither you nor I have you're not a CS grad, right? You're an EC or computer
Yeah.
engineering.
I mean, I'm mix of both EC and CS, but my bachelor's was EC. Yeah,
Your
electronics.
bachelor's was EC degree, right? Likewise with me. And so, like, sometimes like the crypto side can be certainly out of the wheelhouse of things that we were taught as undergraduate students, and during my PhD also. But cryptography has gotten to the point, and I really, really, really don't mean Bitcoin, right? So it's very bothersome that cryptography, to many people, means cryptocurrencies. Cryptocurrencies use advanced crypto, but crypto is a much broader field. So there are these incredibly interesting capabilities that crypto can provide us. For instance, privacy. So when you upload your data to a cloud server for whatever reason, right? Whether it's to get inference from an AI model or any other reason, you upload your data to the cloud for some processing. Crypto can allow you to upload that data in what I would call an encrypted manner, and the cloud can still process your data in an encrypted manner without ever actually having to see what you sent them. So you will get a correct result of whatever it is that you've asked.
So, Siddharth, what do you do other than work? Are you a boring professor, or you do more than AI chips? crypto?
Well, I mean, I love to travel, so I take every opportunity I can. Heading to Mexico City for a few days for the July 4th weekend. So that's something that keeps me busy. And outside of that, in New York, there's just if you've been, there is no dearth of things to do. Theater, it's a very culturally rich city, so I love going to museums, right, when they have new exhibitions and so on. And then you know, I will say, right, I mean, very briefly, I know this doesn't apply to you to some extent, but being outside of being outside of the country that you grew up in imposes a tax. Because I spent a month in Bombay recently. It's just a different feeling, right? Because you know so many people and you have a network and so on. And
Yeah.
for immigrants, I think I spend a lot of time making sure that I have, uh, this is your chosen family versus your we don't get the opportunity to spend as much time with our actual families. You have to like rebuild that somehow, and that's work, right? That takes it's pleasant, but it does take time and effort to do that. So yeah,
So maybe we can expect with those thoughts that you'll be back in India to
oh, I
experience more
hope to
of your.
spend a lot more time in India. And thank you for the opportunity to talk at the India Science Fair this January and so on. It was a really fascinating experience.
No, it was great to have you, Siddharth, and it was great talking about a wide variety of issues today. And I'm sure you have inspired some of our audience with all the exciting things and designing chips using AI. And as you said, let's hope for more democratization of resources for AI. And anyone who has a good idea and can convince that it's a good idea gets the resources to demonstrate what
Yeah.
their technology can do. So thank you again, Siddharth, and hope to talk to you again very soon.
Thank you, Varun. It was a really fun chat, and hopefully, yeah, I'll see you soon. Yeah.